Okay, so let's get started. Let me cite my taskbar. I hope you all had a good spring break, and so in the previous lecture we covered how to add some base map to your package, and for today we want to go over how to visualize vector data, add some functionality to your package to visualize vector data, and we have covered using Podium, also IPyLeaf, how to visualize some vector data. Specifically, we only cover GeoJSON, but there are lots of other vector data formats out there. So previously in those examples, you can see this is the way that you add vector data to the map. It's not too bad. It's a couple lines of code, but our goal here is to make it even easier to visualize vector data. So imagine users are going to use your package, they're just going to create a map, and then maybe just use one line of code, add GeoJSON something, and then they can load the data. They don't have to worry about how to construct a dictionary, how to have a very long dictionary like this to add that to the map. So we're going to make it a lot easier, and specifically we're going to follow this example using IPyLeaflet. For example, this is the one that we use to add, for example, a point or line or a polygon to the map. But what we want is to directly load the data from the internet, or maybe load a file from your computer so that we don't have to read the dictionary. And so in the software development, if you're developing all package, what's the general workflow? Like how do we add new things to your package? And I would like to use the analogy of you're trying to maybe, okay, you already have the house, you already have the foundation, right? You already have the room that you like, living room, bedroom, whatever you like. And now you need to have some design. You need to have your furniture, right, into your room. So what kind of furniture do you like? Where do you usually go to buy the furniture? Do you buy online or do you go to the store to take a look at the furniture, the bed, the desk? You can, of course, you can buy online, but sometimes is it going to fit? Is it going to look good? So nowadays, they have lots of AI that you can like have a room and then you can just play some of the furniture on that. But you can also go to IKEA. They have some of the room like showroom, right? Have you ever been to IKEA? Oh, it's too far away. So the nearest one is in Atlanta, 3 hours. I've been there a couple times. So you can go there, you can see like what it looks like. They have all the things laid out. So this is what we're gonna try here. We're gonna use the one, like use these traditional packages to make things work. And then we're gonna bring this one to our home. And then we're gonna redesign a little bit to make it live even better. So this is what we're gonna try out here in this lecture. And this is how to implement it. So what we want here is to make some working example using other packages. And then we're going to build on top of that. So I'm going to copy this one. We already covered this one earlier, right? So now you should understand if you're using IPyLeaflet, you're going to basically maybe create a map and then have a GeoJSON data dictionary. Then you're going to use this GeoJSON class to pass in the data to the GeoJSON and then add the layer to the map and then display the layer. Make sense? So this maybe just simply, how about this? Let me copy this couple lines of code. And I'm going to open my notebook here. I'm going to maybe just create an empty one, something like here. Don't need this. For X, for X. So I'm going to add a new code blocks. Okay. No, not what we want. We want this one. So I'm going to go to the host website. I'm going to paste this one and run it. Oh, we need to create a map. So we're missing the map creation. Maybe somewhere here. Okay, so let's create a map. What? Okay. Let's do this. IPyLeaflet.map. because otherwise you need to import the map class. Let's just tweak. Oh, not so good. I'm going to maybe import IPyLeaflet. Okay, so this is the basic one to create a map, and then let's add some GeoJSON data. So I'm going to go to this one here and simply copy, right? And then I'm going to maybe do it here. We can move this to up a little bit, put it at the top. So in general, when you're doing the testing, when you import some packages, usually we want to separate them, okay? Don't try to mix your code block with the import. It's not a good practice because you're importing the library, you only need to import once. You don't need to import multiple times. So I'm just run this one and then have this. And now you have a point in here. So, but how do we add a GeoJSON? How do we add a file, right? You don't want to do the hard coding like this one. So what we need to do is to figure out how do we actually read a GeoJSON dictionary and then plot it on the map instead of doing the hard coding. And I'm going to use some examples from my GitHub repository here. So I'm going to go to Open Geospatial, and I'm going to go to the datasets. Under the releases here, so I'm going to go to maybe, I think there should be a US, okay? So I have some sample data here. For example, US states, US cities, US counties. So maybe let's try out this US states. We have this GeoJSON file here. If you click, it's going to ask you to download this file, but we don't want to download the data. We want to actually visualize the data directly. So what you can do is just right click, copy linked address, okay? So right now we are not using our package yet. We are just using IPyLeaflet. So we're trying to figure out how to make things work. And what you need to do here, we can use GeoPandas. So I'm going to import GeoPandas is GPT. Okay. So this is the convention to import GeoPandas, and then I can just give a URL equal to Ctrl+V. Okay. So this is a link to the GeoJSON dataset. Once you have this, now we can use GeoPandas to read the data. So you can say GDF equal to gpd.read file. So GeoPandas can read the data directly from internet. So let's run this one. And you see it's done. Now you can just say GeoPandas hate a GDF. Look at this. So now we have the data read directly using this one. And so how do we visualize the data using GeoPandas? Remember? We covered it. Explore. Yeah, exactly. So you can just say gdf.explore. EXPLORE. Okay. On this. Nice. So now we have this one. But keep in mind, the explore function utilizes volume. But here we're using IPyLeaflet. They are two different backends. So what's the differences between volume and IPyLeaflet? What's the difference? Remember, we covered it. Volume is one-way street, okay? IPyLeaflet is two-way street. One way means when the map is created, it's a done deal. You cannot remove anything, you cannot change anything. All you can do is zoom in and zoom out. But IPyLeaflet, it's like Lego building blocks. You can change it there, you can add control. So we don't really want to use this one to doing the visualization. We want to use IPyLeaflet. So I'm just going to delete this one here. All right. So once we have this, now we can actually turn this one into a GeoJSON. So this here, this is a geodata frame. So GeoPandas can read a variety of vector data. Imagine you might have GeoJSON, you might have shapefile, you might have GeoPackage, or any other data format that you use. GeoPandas might be able to read that. So we're going to use GeoPandas to read the data. But in order to use that in IPyLeaflet, we need a GeoJSON dictionary. So how do we convert this one from a GeoPandas geodata frame to GeoDictionary? Again, you can just type GDF just to show you what's this one, the data format. So this is the geodata frame. So basically it's a data frame with the geometry column. So it's built onto the pandas. We already covered pandas. So how do we turn this one into a GeoJSON? Very simple. GDF dot underscore underscore, and then I think the geo interface. I know this looks like hidden. It looks like, why do they use this name? I have no idea, but this is kind of a hidden feature. Underscore. So what it's doing is converting the geodata frame to GeoJSON. So let's run this one to see what it looks like. It looks like this. And it's a dictionary. Type is feature collection, feature, blah, blah. It's a very long file. So if you just click text editor, this is the entire content of the file. It's exactly the one like you download it from here and then you open using TXT. So for example, I download this one to my computer and then I just going to open this one. You see, it's a very long document like this, a lot of points, a lot of coordinates. So do you want to copy this one, pull it directly into your notebook? Yes or no? No. It's got overwhelming for your notebook. So that's why we don't want it. And that's the reason why we use GeoPandas to read the file and then just use Geo interface to get the dictionary. It's just available. It's not like it doesn't have to show the content. So now with that, let's see what we can do here to add this one to the IPy leaflet map. So I'm going to go back to here. And now we have this dictionary. We don't even need to display it. You just delete this one. So all I need to do here, look at this. All I need is just one line of code. GDF dot underscore underscore geo interface. And that's it. So let's run this one, see what happens. Boom. So now we have the data. Very nice. So how many lines of code you need to write? Not too many. I can delete this one, and maybe change this one to what's the coordinates if you want to center in the US? Remember? I show you, right? For the globe and also for the US. What's the latitude? 40. You didn't practice enough, otherwise you know. Okay, 40 negative 100, and then zoom level 4. So this should be roughly around the US. Exactly. So right now we're zooming to the US. This one also covers Alaska, but we're just focusing on the continental US. This is it. Of course, we can hover the mouse, we can change the style, everything, but right now, I want to keep things simple. It's basically, how do we go from here and then add this one to your package so that users just need one line of code, they can add the data. So how do we do that? For the import, we don't really need it. I can just put it at the very beginning. And all I need to do is move this one inside here. Okay. And then move this one inside. And that should be it. I did twice. Okay. So now I have the map. And the function should be pretty flexible. So right now, all we need to do is change the URL, right? So I show you right now using the US state. I can change it to anything else. I can maybe use a US region or US county or even countries, whatever you like. So I can change this one, maybe US Southeast. Okay, copy the URL, come back to here, replace the link, paste. On it. Okay, so now I have the map centering here. It doesn't really matter. We can also actually get the central location if you want to, but I'll show you later. For now, let's just zoom in here. Maybe add another function. How do we, when you load the data, how do you automatically zoom to the map? Zoom to the layer. So for example, assume that you don't know what's the center. For example, when you create the map, you can center right now because I'm acting in the US state. I know the data layer is going to be centered around in the US. But if you add a data layer somewhere else, right? How do you just like in desktop.js, when you drag the data layer to the desktop, it automatically zooms to the data layer. Right now, this one doesn't. This one is like, it's going to fix at a certain location. So I can also do it here. For example, 0, maybe 20, 0, and then zoom to, and see what's going to happen. It's going to look like this. It's not zoomed to the data layer. If your vector data is very tiny, it's going to be very hard to see. So how do we actually zoom to this particular location? What do you think? What's your thinking process right now in your mind that I want to add the data layer, I want to automatically zoom to the data layer when I load the data, I add the data layer to the map so that user don't have to zoom in and zoom out. What do you think? What do you need? Exactly. You can find, so what you need, right? Because you're going to zoom to this area. So you can either find the center of this layer, or you can find the bounding box of this data layer, and then you just zoom automatically to that. That's it, right? So in GeoPandas, there's a function that you can actually get the bounds. So for example, once you read the geodata frame, there's one called GTF. So total bounds. Okay, it don't give you this bounding box. So this should be the lower left corner. This should be the upper right corner. So this will be the bounds, and you can turn this one into just maybe a list or something. So I can turn this one maybe into a list. So we're turning from the array, NumPy array to a list. Or maybe just use the list directly. You might be able to do that. So in the map, there's one called m.fit bounds. Okay. And so the fit bounds function accepts two parameters as a list, lower left corner, upper right corner. So you need to pay attention right now using Copilot, see, automatically feed it in. So what it's doing is like a list of two items. So this is the first list. This is the second list. I'm not sure if it works or not. Let's try it out. Nice. So what it's doing is actually getting the coordinates from the, because this one here, the total bounds in GeoPandas, again, this is really confusing. And this is something you always need to pay attention. So if you look at this number, is this one the longitude or latitude? Longitude. This one? Latitude, right? So it's longitude, latitude, longitude, latitude. So basically it's x, minimum y, maximum x, maximum y. So the bounding box here is basically maybe somewhere here, this corner, the first one, and the other one will be somewhere here. So the lower left corner and upper right corner. But in IPy leaflet, the fit bounds function accepts 2 points, and then it's latitude first, longitude. So this is why here, GTF total bounds, number 1, then number 0. So what is that? It's basically this one first, and this one. Put into the list here, and then this one here, this one here. It's rather confusing. If you flip the result, you're not going to get it. So this is something you sometimes need to be very careful. Different packages might use different convention. Is it latitude first or longitude first? So this is basically what we need to do is to zoom the data layer automatically to the map. So in that way, we don't have to worry about like to set the zoom, the center by ourselves. So I'm going to go here. I can show you. I say going to maybe, let's do this. So what we can do is to, okay, add a GTF, add a GeoJSON, add the layer to the map, and then we're going to zoom to the layer. So here, I can say bounds equal to GTF total bounds. And then, perfect, I like it. So now, take a look. Although the map initially we created around the globe, and the zoom label is 2. So it's supposed to be the global map. But once you add the data layer, we automatically feed it to the bounds. So now, if you run this one, see, It's automated. It doesn't matter where do you start the map. It doesn't matter. See? Do you see that auto zoom effect? So with this code block, this snippet, now we can integrate this one to our package. So how are we going to do that, right? Because with this, you can visualize pretty much any vector data. So it can be line, it can be polygon, it can be anything. So for example, let me try another data set. I may be going to use this one. So I'm going to use maybe this should be one called cable. Yeah, cable.geojson, for example. This is a line, undersea cables. So it's a GeoJSON. Again, it doesn't really matter. I'm going to come here, replace this. See? Oh, skip field coordinates. I'm not quite sure what happened. But these are all the lines, undersea cable across the continents. This is where right now we have the internet, okay? Internet come from somewhere. So if you're in other countries, there are different servers. So some of the underlying undersea cables, it is like going around different continents. So this is outer line. It can be polygon. It can be anything. So let me change to another one. Maybe, okay, let's add a continent GeoJSON. Replace it. Okay. So I don't have to worry about it's going to zoom automatically to the data layer. You can try it with any data layer. This is not super complicated. It's a couple lines of code, but can we make it even easier? Just one line of code. Create a map, add the GeoJSON, display the map, that's it. You don't have to worry about like how do I do it using GeoPandas, how do I construct the GeoJSON class, add it to the map, and then get the total bounds. We can simplify everything. So this is kind of the basically conceptualize how are we going to do this. So what information do you need? If you are built on top of some other packages, you want to basically at least get a working example. Don't directly go to your package and then start doing the coding because you need to eventually test your package. Unless you know what you're doing, it would be better to just maybe open the notebooks, test things out, make it work, and then you simplify it. Don't go directly to your package because unless you're very expensive, you might not know like how to do that. So next, let's start building our package. So for here, in the last lecture, we did cover how to add a base map, add some Google map. But right now, what we want is to add another function so that we can add some vector data. And Copilot is wrong this time, okay? def add, what I'm going to add is to go add GeoJSON. And then parentheses. Oh, this is nice. I may not like it. I'm going to maybe, because I already have example, so I don't want this one, right? But keep in mind, if you're adding a function or measures to a class, the first parameter is always self, okay? Otherwise, it doesn't belong to that class. Self means it's like tied into that class, to this object. So you always need to make sure that you put this self at the beginning. And then the second parameter, what should we use? So go back to this example. If you're trying to lower the data GeoJSON to the map, right? So what do you think? By looking at this example, what do you think? What parameters should we create so that the user can customize the input so that it can be used to load any data? What do you think? What kind of thing you want the user to customize? Just a couple lines of code here, right? What do you think we can change, right? So earlier you saw me changing stuff. What did I change? Just the URL, right? Anything else? Like you can also like zoom to the bounding box, zoom to the layer. But I can allow the user to control. Some user might not want to zoom that. They might add a bunch of other data layers. You don't want to zoom in and out for when you add different data layers. So maybe you can have another parameter, allow the user to select whether they want to zoom to the layer or not. And that should be it. Just two parameters, it should be enough. So come back to here. Okay, look at this one. I think the easiest way would be Think about this. The map creation is not controlled by the GeoJSON, right? You don't care about the map. It can be created using a package. But what we really need is something like this. Okay, so I'm going to just copy this. See how I'm going to do that. Control V, and make sure that you indent the data layer. All right, and like this. What else do we need? So right now we have the URL here, and we'll just read the URL. But we want to make it more generic because user can read from URL. They can also read from the local file, right? It doesn't have to be URL. So we want to give a parameter name that's more generic. So I want to use the name called data, okay? And then the other parameter can be, okay, zoom to layer, for example. By default, I'm going to set 2, okay? You can also have other keyword arguments. Right now, we just put this one here as a placeholder, but later we can customize it. So next, then we need to remove this line, right? Because the URL is going to pass inside here. So we don't need the URL hard-coded. Don't do hard-coded in your package. Don't have any file path C drive and then blah blah colon. It's very bad, okay? Bad practice. Your package should be something generic that allow the user to customize. So what we need to do here is to allow the user to read the data from the using the GeoPandas. So right now here you see the kind of yellow clear line here. That means the package is not in there. So we need to import it. You can do it 2 ways. You can import the package within the function, or you can import the package at the very beginning here. The recommendation would be if your package is very large, or it might be challenging to install on some computers, then you put it inside the function. If the package is like a library, it's the built-in library, or it's something else, for example, import OS or something like that, you put at the beginning. So that's actually, because you know it's not going to run into any errors. So for me, for example, if you ever need the OS library, this is a built-in library, so I can just put at the beginning. But for GeoPandas, you need to make sure that you have the GeoPandas, for example, installed here. Then it's okay to put it at the beginning. Import GeoPandas here. But if it's only used by 1 or 2 functions, you don't want to import at the beginning. And this is kind of in desktop GIS. If you ever use ArcGIS, right? In the past, you need to check the extension, check the box when you want to use it, because you're going to use some resources. So if it's something that's going to be used a lot throughout your package, you're going to do it here. So import GeoPandas, GPT, all right? So this is going to import the package, and then we're going to read the data. So right now, instead of URL, is the data parameter, right? So coming from here, so I'm going to read the data, and then, oh, now you have the conflict, so it's no good. So you might need to change this one to something else. Because we're reading the data, now this has become a GeoJSON. So I can change it to a name called GeoJSON. And then this one here, you also need to change to GeoJSON. Whoops. All right. So GeoJSON. Also, you will see this one, GeoJSON, because earlier, when we use this one, it comes from this because it import the GeoJSON from IPy leaflet. So right now, this one is not imported. But at the beginning here, we already import IPy leaflet. So we don't need it to import again. We can just say IPy leaflet .geojson, right? So it's a class. So we just import once, we can have access to all the stuff. And then, can we use M here? Can you use M here inside the class? No, okay. So make sure right now the class is called self. Earlier, because M is already an object created, but for you should use .self, just like what we did in the past. So this is a class right now. So in order to get access to the object, you need to use .self, not M, okay? So this is something you need to pay attention. So I'm going to m.self add layer, and then similarly m.fit bounds. But because right now we allow the user to control whether on to zoom to the data layer or not. So this one should not be run by default. It should only be executed if the user chooses to. So what we can do here is to have a conditional statement. And so how do you use the conditional statement? If zoom to layer and indent it. That's it. To be done now, right? Now we have this add GeoJSON data layer. Under the hood is going to read the data. Oops, I have something wrong here. GeoJSON. Okay, Control S. So we're going to use GeoPandas to read the data. No, there's something is wrong. So you can say maybe this one called layer. Okay, so what now? So we read the data using GeoPandas. We get the GeoJSON. Then we construct the GeoJSON layer, and then we add the layer. Also, you can decide if the user says, okay, I want to zoom to the layer, then you execute these two to zoom to the layer. And that's it. It's simple. We can have more complicated stuff, but for now, this is just the default settings. So let's come back to here. Play the output. Now we can start debugging our package. So we're not going to use IPyLift anymore. I'm going to use my package. So let's run this one, okay? And m.equal equal to GeoDV.map, display the map. Okay, so by default, we're creating just a simple map. So now we can try it out. Where's the layer? I think I deleted it. That's no good. Let me go back to here. Maybe use this continent. Okay, copy. And URL equal to this. And then m.add GeoJSON URL. Let's see if it works or not. Nice. And it zoomed to the layer automatically. So right now, we just simplify from earlier. How many lines? Maybe 7 or 8 lines. Now we only have 2 lines. We create a map. We point into the data. We load the data. We display the map. Is it better? Easier than the previous method? You need to import GeoJSON. You need to you import GeoPandas. Everything has been taken care of under the hood. And so let's try out the other one, like to test the zoom to layer methods. So let me go to the release. And then I'm going to go to the US here. And let me find the Southeast. Right. So earlier I showed you US Southeast. Right. So by default here, replace it. Nice. You see, it zoom automatically to the map. But the user can control, right? So zoom to the layer equal to force. You set the force, that means right now it's not going to zoom to layer. So because by default, our layer with the map is going to center at the latitude 20, longitude 0. So it's a global map. And if the user choose not to zoom to layer, it will look like this. Isn't it better? Then right now we can go from maybe 7 or 8 lines of code, this, and it's so much easier to use. Then the user right now can customize the whatever lines URL. It can be also from a local computer, right? So earlier I showed you, I've downloaded a file to our computer, for example, US.state.geojson. So you can actually load the file from a computer. It doesn't have to be from the internet. Let me show you. I'm going to copy this URL and I'm here, paste, and then US states. Oops, what's happening? Supposed to be able to US states GeoJSON. Okay, it's coming up. Run it. Same thing. You see, this one is so much faster because it's reading the data from a local computer. I can restart the kernel and we see how fast it is. Okay. If you're going directly to read the URL from the internet, it needs to download the data. You need to stream the data and then turn it into a GeoJSON. But for local data set, it can be anything. So Super cool. What else can we do? After you have this, is there anything you can think you can improve? Elevation? Yeah, you can study elevation. Maybe we'll cover it in another lecture. Right now, it's a little bit complicated because you need to change the color first. You need to have, right now, the legend doesn't really mean anything. It's not a cross place map. It's just, it's just blue color. It doesn't mean anything. There's no population. There's no the color right now. There's no color. But maybe you can, like when you hover your mouse on some of this, maybe you can highlight or something. Right now, it's just blue color. It doesn't do anything. Right. So if you want to highlight something, you need to set the hover style to change it to something else. So this also customizes so that the user don't have to worry about. For example, when I hover at a certain polygon, I wanted to highlight the boundary in yellow color. It would be better. So I think in previous lecture, I think we have covered it, right? Where is it? At real control. I think there should be something like here. Hover style. I think this is the one, right? So when we construct the GeoJSON data layer, you can pass in a hover style into that, so that when you hover something, you're going to change the color. So let's go back to maybe, let me show you. I'm going to come back to this one. Look at the source code. So where do we add the hover style in here? It's in here, right? Inside the GeoJSON. But how do we add it to the function so that the user can customize? So the user can provide the hover style. If you don't provide, you get set a default one. So how can we do that? Of course, you can add a hover style somewhere here. You can just copy the entire one. So let me go back. 10 minutes. Okay. Let me come back to here. I'm going to maybe, oh, not this one. So it'll be like this, right? It'll be this one. And you can just copy and paste here. Control H. Make sense? Data, zoom to layer, hover style, blah, blah. Color, I'm going to change to yellow. This array, I don't need it. Fill opacity. Okay. Just this. So right now you see it's gray out. So anytime you see it's gray out, that means that parameter is not being used in your source code. That's no good. And because it's being used by the GeoJSON, we probably want to just come here and hover style equal to hover style. I can also allow them to accept other parameters. So if you have like star keyword arguments, basically takes a dictionary. It's going to unwrap the dictionary, then put everything in here. So let's run this one and see what happens. So by default, when you hover your mouse, you're going to change the outline to yellow color. And the fill opacity, we can keep it as default right now. So let's rerun this one. Run it. All right, so now hover my mouse. Isn't it nice? So it's just one line of code. Now I have this highlight in yellow color. Only just adding one default parameter. Compared to earlier, it's just like it doesn't do anything. So this is so much better than this, right? You can change to red color. You can change to whatever color you like. So this is how you can customize the default settings. And so when you look at this one here, sometimes if the parameter is like way too long, you can set it as none. So if it's none, then you inside, you set a default something. So I can do it like this. It's not a good practice if your default parameter is like very long. So I will just do it like this, equal to none. And then inside your source code, you can do it like this. If hover style is none, and then hover style equal to this. This is also a good way. Oops. Why did I do this? Yellow. Okay, this. And then fill opacity maybe change to 0. If I just want to highlight the outline, I don't want to fill anything, then I can do it this way. Okay. Control S. All right, done. So let's look at it. Restart the kernel. Run this one. See? So now if we zoom in, hover your mouse, you see it's going to be transparent. Right now we only have the yellow color in this. Or if you think it's like, because the yellow color you see it is not very obvious, because it might be actually blocked by the blue color at the top. So what you can do here, maybe you can have a field opacity to maybe 0.1 or 0.2 or something to make it a little bit more obvious. All right. So see, now it should be a little bit better. And the user can customize it easily. So for them, they can just say hover style equal to field color equal to red or something. Then in this way, they're going to use the parameter that they provide. So look at this. Now when I hover my mouse, I really want this one, the default setting, to zoom to wheel, so that save so scroll wheel zoom equal to true, right? So I don't need to zoom in using the button. You will using your scroll wheel. Right now, let's do this again. Okay, now I can zoom in. See, isn't it nice? You can do many other things. This is just one way you can customize the function to add this. I think for the level 6, it's asking you to do exact same thing. You can add GeoJSON, or you can have a very generic thing called add vector, and then use GeoPandas to do anything for you. So let me show you how to do that. I'm going to show you here. Or maybe add shape file. Okay. DEF. Okay. Add. Maybe just SHP, just to be short. Okay. And under the hood. Oh, nice. So it's already doing for me. So passing the data, read the data, convert to EPSG 4326, and then get the GeoJSON, add the GeoJSON. But I think for this one, we don't really need that. We can just do it GeoJSON. And then when you add a shape file, because you can read the shape file, you can convert to GeoJSON. Once you have the GeoJSON, we can call the function that we created earlier. So this is, in that way, you don't need to reinvent the wheel. So we can just use, look at this, self.add GeoJSON, GeoJSON keyword argument. Please. So what this one is doing, if you provide an Esri shape file, I'm going to read the data and then just convert it to EPSG 4326, get the GeoJSON, and then I call this function. So in that way, everything that we have created earlier, it can also be usable. So now let me show you how do we test this one. So I'm going to just restart the kernel. So let's find an Esri shapefile here. I'm going to go to, I think the US, this one, US, maybe US state. There's a .zip file here. This zip file actually contains a shapefile inside, but GeoPandas can read the file directly. So let me show you how I'm going to do that. I'm going to copy this URL, and let's come back to here. URL, just replace this one with a zip file on the internet. And then, so all we need to do here, just add SHP. Make sense? I have this web file hosting on the internet. GeoPandas is going to read the file, convert it to GeoJSON, and then it's under the hood, it's going to call add GeoJSON function. So let's try it out. Oops. Feature collection. There might be something is weird. Don't be. So let me download this one just to my computer. For now, just to test things out. Sometimes if it doesn't work, don't worry, we can fix it. So US state, we have the zip file here. We can just unzip the file. So I'm going to just extract here. Right, so now we have this US state. Inside here, it has the GeoJSON, it also has the .ssp. So I can just copy this URL. And then from here, This will be the file to our local file path, and then US states.shp. Look at this. And I hope this should work now. Whoops. Data source error, blah, blah. Huh. Yeah, this should work. EPSG at GeoJSON with the data. Oh, just the. Oh, it might be the GeoPandas issue. Okay. Let's try the GeoJSON. It should also work. GeoJSON. Hmm? At JSON. Okay, at GeoJSON works. I'm not quite sure. I think something is wrong with the GeoPandas installation. It doesn't read any swap files on my computer. It's a little bit unexpected. Let me test it here. Kind of running out of time, but let me see here. .shp and oh, GeoPandas. D read file and URL. Oh, box. So this is here. Do something wrong here. GeoPandas to PSD. Yeah, it should be the same. So I don't know what's the issue here. HP. Data source. Oh. Okay, we are out of time, so we will continue in the next lecture. But it should work. So basically, at the end, we can just add an add vector function that can allow us to add any vector data. But we fix this one in the next lecture.